Most of the people have access to the commodity hardware or GPUs, and that is why, for their starters, they always go with the quantized version of the large language models. I have done hundreds of videos on such LLMs, and the most common question I get as a comment in the videos is that whether this quantization, whether it is in GGUF format or any other format, does it reduces the quality of the model? The short answer is yes, but then it really depends. Let me give you a bit more detailed answer in this video. First, quantization is a technique used to reduce the precision of the weights in a neural network model from floating point numbers to integers. This process is key for compressing the model size, reducing the memory footprint, and potentially speeding up inference, making the deployment of LLMs more efficient, especially on hardware with limited resources or for applications requiring low latency. Now, in a standard full precision model, the weights are typically stored as 3-bit or 32-bit floating point numbers. By quantizing these weights to 6 bits per weight, each weight can be represented by only 6 bits instead of 32. This drastic reduction in bits per weights leads to a significant decrease in the model size and can also speed up computation, as integer operations are generally faster and more power efficient than floating point operations on many hardware platforms. I have used the term 6 bits per weight or 6 BPW. This is mainly used in the context of quantization for LLMs like GPT or Llama or any other, and that refers to 6 bits per weight. The challenge with quantization, especially aggressive quantization schemes like going down to 6 bits per weight, lies in maintaining the performance of the model. The reduction in precision can lead to a loss of information, which might degrade the model's accuracy or capability to generalize. Techniques such as fine tuning the quantized model using advanced quantization methods that include per channel quantization or mixed precision and employing post quantization calibration are often used to mitigate these effects and preserve as much of the original model's performance as possible. Here is a good rule of thumb. Good quantizing works well down to around 3.5 bits per weight. The behavior is increasingly dumb below that. Reliability is different, totally different, and you will end up with percentage of your inference going wrong with quantization below 6 bit per weight. And you might have to rerun an inference every so often. And you might have seen me doing that in LM Studio when I'm running the model. But make no mistake, models are still smart even at that quantized level. Quantization generally speeds up inference, not slows it down. In the broader context of deploying LLMs, quantization is one of several strategies employed to optimize models for real world applications, alongside others like pruning, distillation, and the use of efficient models architecture. Now, you can look at from the creative writing angle too, because as far as creative writing is concerned with the help of large language models, the thing is that you don't notice much difference between the quants of the same model, or you don't really care about the size of the model. I have used 70 billion models, I have used 130 billion, and I have used 7 billion models. But the thing is that they are pretty much indistinguishable from 7 billion model, and there are heaps of them. Where the big model really shine is that when they're actually able to understand what they are parsing. So, for example, the thing is that if you are using a mixture of models like MOE, like Mistral or Mixtral, that really shines here because of its expertise nature. But the best writing models are most limited to a smaller context of under 10K context size. which keeps them speedy, but means you have to rely on tricks to give the AI a decent memory of the story. So we can also say that quantization also differs from use case to use case. Now, this is not a hard and rocket science because you are really reducing the size of the model. And in order to do that, there is a trade off. There is always a trade off. So make sure that you use the quantize level and the quantize bits of model according to your use case. If it is a very high number crunching, then you need to quantize the model as little as possible. But if it is just creative writing or general inference, even a quantized version of 7 billion should be good enough. Let me know what is your approach of quantization. Very keen to know because I'm more than sure it's an evolving field. It's not a science at the moment, it's an art, sort of art. So very keen to know your process of quantization. What sort of quantization you prefer? For example, if you are using LM Studio, do you go with font level 1, 2, 3, 4, 5, or which one? So it would be really good to know. If you like the content, please consider subscribing to the channel. If you're already subscribed, then please share it among your network as it helps. Thanks for watching.